Hello. I was helping my daughter with her geometry homework, and she was studying frustums and the surface area. And I was all busy showing her how to find big cone and then subtract away the small cone and be left with the frustum, both for volume and surface area. And she said to me, "No, Mom, there's just a formula for how to find the surface area." So, of course, I went running to my whiteboard to figure out how to derive her formula from my method. Let's take a look. And by the way, if you want to try this first and then watch the rest of the video, the first thing I'll do is I'll show a screen of the formula, then pause it, play around on your own, and then come back and see whether your solution matches my solution. Okay, so first of all, a frustum is a cone that's had its nose chopped off. And so if we call this top radius R1 and the bottom radius R2 and the slant height between them L, then the formula she presented me with is pi R1 squared plus pi R2 squared plus pi times R1 plus R2 times that little truncated slant length. So the pi R1 squared and the pi R2 squared, okay, great, we get that, that's this. But where does this come from? That was the part that I was interested in. So if you want to play with this on your own, pause the video here, go geek out, and then come on back. So assuming that you've played on your own and you're ready to keep going, let's go ahead and draw in the missing part of this cone. Okay, so forgive my drawing skills, and let's go with these right angles and not the fact that this thing looks like a leaning tower of Pisa. Essentially, when we complete the cone, we wind up with a cross section that are two proportional right triangles, right? They both share a right angle and they both share a top angle, and AA is enough for similarity. So if I further define this L and I say, let's call this length L1 and call this length L2, then I could set up a ratio that says that my radius 1 over my radius 2 will be in the same proportion as my L1 is to that full side, which would be L1 plus L2. Okay, so that is my ratio of these two similar cones, and it gives me a way to start to connect the variables of R1 and R2 with the variables of L1 and specifically L2, which is the one that was part of the formula my daughter gave me. Okay, so what I also know is that the formula to find the wallpaper of my cone is pi times the radius times the slant height. So for my big cone, that would be pi R2 times L1 plus L2. And then from that, I would need to subtract the wallpaper of the tiny cone. So that would be minus pi times R1 times L1. So that's the formula based on my method for the wallpaper, right? Big cone minus small cone wallpaper leaves us with Frustum wallpaper. So my question is, there must be a way to use this ratio to take this and make it look like the one in my daughter's formula, which was pi R1 plus R2 times L2. So the first thing I did was I took this and I cross multiplied it, right? Multiplied this times this equals this times this, and ended up with R2 times L1 equals, and then I distributed this through R1 L1 plus R1 L2. So if I take this and distribute this through as well, I see, so that's distributing this into both of those, I see that I have an R2 L1 and I have an R2 L1. So I'm going to go ahead and substitute this in here. And now I'm going to distribute that through to get, and I've got pi R1 L1 minus pi R1 L1. So those two disappear. And when I look at these two remaining terms, there's a pi and there's an L2 common to both. So if I factor those out, there I am with my daughter's formula. Pi times that little truncated slant height times the radius of the top plus the radius of the bottom. And that gives me the wallpaper of the frustum as derived from the proportions ratio of top cone to full cone, which I cross multiplied into that, substituted into the concept of wallpaper of full cone minus wallpaper of top cone. When I put those two concepts together, I distill them into this much more elegant way to find the wallpaper of the frustum, and then I just add in the area of my top circle and my bottom circle. So, how'd you do? Did you come up with the same? Did you find an even easier way to derive the formula? Let me know in the comments. Check out these other geometry videos and my geometry playlist and my brain teaser playlist. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.